Okay. Hi, everyone. Welcome to the last meeting of the year. It's good to have you all here. If you're joining for the first time, welcome. So today we're going to have a presentation from Angelo Corsaro, who's here with us. He works with Zetascale, the makers of Zeno. And we're really interested to hear some more about this middleware that the ROS community is starting to use, and anything security related. So please have your questions, comments, whatnot. I will send the floor over to Angelo. I see that you shared the slides on the chat.
Yes, absolutely, I did.
So
I
yeah.
did, and yes, you should be able to get the slides there. And I wanted to share something else with you guys, because we just had yesterday our second user meeting, and there were quite a few robotics companies that were presenting. So if you're curious to see what people are doing with Zeno today, you can also take a look at this. It's long, it's 4 hours, but you can skim, and we will be producing also individual videos for the various end user presentations, okay, so that you don't have to jump on more than 4 hours video. But that's the user meeting that happened today. Okay, so with logistic in place, I guess we can get started. So I'll start with sharing my screen, and as I do that, perhaps a very brief introduction about myself. So as Florencia mentioned, I'm from Zetascale. In fact, I'm the CEO and CTO of Zetascale, and the project lead of the Eclipse Zeno project. Can you see my screen, by the way?
No, not yet.
Okay, let me try again, because it's since yesterday that Safari was kind of playing silly with this. Yeah, because I mean, from my perspective, it's sharing, and maybe what I need to do real quick. Yeah, share the screen. Still not seeing anything, right? So let me rejoin with Firefox. Just a moment. Sorry for that.
Yeah, sure, no problem.
Okay, and I am back. So let's try again to share the screen. This time it should work. I mean, it's since the latest update that I have some issues when specifically with, yeah, I think now you should be able to see my screen and my slides. Isn't that true? Can anybody let me know? I cannot see I'm full screen.
Yeah, it's okay.
Okay, great. So I would say, let's go. Let me hide this. And let's start with the presentation. Okay, so the plan for today is to look into Zeno security model and tell you what we have available today and what's coming up, okay? And then keep it quite open. If you have questions, I'm pretty familiar with DDS2. I mean, it's quite sometimes that I left my role as DDS co-chair, but for those of you that don't know, actually I was one of the 3 persons that started DDS standardization and DDS working group back in early 2000, and left for various reasons, I think are pretty much known, in 2015. I left my position there decided to leave as a co-chair to start the Zeno project. Okay, so so I'm pretty familiar with, let's say, or more than familiar also with the DDS security. So if there are some curiosity on how the two compare and you know, eventually difference, don't hesitate to ask detailed question. I mean, that's okay with me. Okay, so let's get started trying to understand, first of all, what Zeno does. More importantly, what is the model, and what are the primitives that are supported, so we can understand then, you know, what we need to secure in a typical Zeno system. Because some things, if you're familiar with DDS, will be similar to DDS. Certain other things are slightly different, and hopefully you'll get a gist of that. Okay, so starting with telling what is Zeno. Zeno is a kind of a strange beast, because when you look at superficially, some people think it's just a PubSub protocol, but in fact it isn't just a PubSub protocol. Zeno is a protocol that puts together primitives for publish, subscribe, and distributed queries. And in fact, by doing that, we are able not only to cover the usual case for data in motion, which is typically done with PubSub technology, but also we are also able to deal with distributed queries and use the primitive that we use for doing distributed queries also to trigger distributed computations. Okay. I don't know if any of you are familiar, for instance, on how we map ROS to abstractions on Zeno. But just to give you an idea, when mapping ROS to abstraction, and with that I mean, in ROS 2 you have publisher, you have subscribers, you have services, and you have actions, right? And all of those are mapped into various combination of publisher and subscribers. In Zeno, for instance, a service is not mapped to a couple of publisher and subscriber, but it is mapped to a queryable. And that's a far more efficient mapping. If you want to understand, the implication and how the mapping that we do in our ROS2 bridge, there was a webinar that was done by Julian, I think last week, which again is on our YouTube. And again, I think that will also give you a hint at how we rebuild the ROS graph on Zeno and how the RMW Zeno is being built. Okay, because we're working quite closely with Intrinsic, and some of the, quite a few of the ideas that we have in the ROS2 bridge are being taken as a reference for the Zeno RMW. And that to say that again, Zeno is not just PubSub, and in fact, it's very efficient for PubSub for sure. But I think if you really want to exploit the full power, you need to take the time to understand what the query does. And we'll, I will give you the intuition around it. Then for the curious, I can give you some reference that you can check offline. Okay, so other important things to understand is that when we designed Zeno, we wanted to make sure that this protocol was really able to run from constrained devices and constrained networks and perform, as well as run on high-end or enterprise network and hardware, and also perform. And if you look at how protocol have been designed, up to before Zeno, I would say, is that they were usually designed for kind of a subsystem, what today is a subsystem in a system that spans from a microcontroller to a data center. So you would have protocols that were designed either to run in very constrained environment or to run on usually non-constrained environment. And then, depending on your definition of constrained, you could take one protocol and push it less on or more. And I'll give you some concrete example. If you look at the wire overhead, right, even protocol that advocate or position as being, efficient, but still target, I would say, the enterprise world, the wire overhead when sending data is, at least several tens of bytes. And if you're trying to run on a constrained network that has an MTU of 20 bytes or 127 bytes, then every bytes count. So you have to be very careful how you design your protocol to make sure that you minimize your wire overhead on one hand, but then you don't jeopardize performance. And so things like even the sequence number and the resolution of the sequence number becomes tricky, because all of a sudden, what is the good resolution for a sequence number? If I'm running on a constrained network, I would like it to be very small. If I'm running on a high latency, high bandwidth network, I need a very larger resolution for my sequence number, perhaps 32 bits. And so how do we do? So in Zeno, besides careful protocol design, there are lots of things that we negotiate through session opening We'll get back to session opening in a moment when it concerns to security. But for instance, the resolution of the sequence number is one of those. Now, getting back to where this protocol sits, as I mentioned before, we wanted a protocol that was able to run, from the microcontroller up to the data center. And the embedded world, it's wild, right? It's very heterogeneous. You can't assume that we always have a network, right? Or that you want to run on top of IP. And so what Zeno requires is just a data link. And in fact, conceptually, what we require is a packet-oriented data link, okay? So now I said that, and on my slides I have serial, and you might say, hold on a moment, serial isn't packet-oriented, so how do you do that? Well, because for non-packet-oriented data links, we have a little, like an extra MAC layer or Zeno MAC layer that makes the transport packet-oriented, and then on top of that, you can do a regular Zeno transport, okay? But so what we need in order to run Zeno is just something, right, that looks like a wire on which we can send best effort packets and get on the other and show up maybe on the other side of the wire. That's it, okay? Then we can run at that level, we can run at network level, we can run at transport level, and as such, besides supporting things like serial, we support TCP, UDP, QUIC, Bluetooth, OpenThreadX, Unix socket, and we also have built-in shared memory. I won't have the time to cover shared memory today. That is something very important in robotics and automotive. The only things I want to mention is that our shared memory design, it's quite different from the traditional shared memory design if you have in mind a product like ISORIX. What do we mean with that? That our shared memory design is decentralized, okay? So there is no single daemon. And something else that you need to realize is that if you take something like ISORIX, right? ISORIX has been written and implemented as a way, essentially, to do IPC over shared memory within a single host, right? In Zeno, we already have a way of communicating. And so we leverage that in order then to build a distributed shared memory management with, by the way, automatic memory management that leverages Rust. And talking about Rust, the Zeno protocol is written in Rust, with the exception of Zeno Pico, which is the version of Zeno that we run on microcontrollers. Eventually, we will have a Rust version for that as well, but the Rust on microcontroller, from our perspective, just start maturing. There was, I say recently, although it's more than 1 year, a very important contribution to make Rust more usable in embedded. When I say embedded, I mean like bare metal ARM, notably the Embassy async runtime and a few other things. But still, for deeply embedded devices, the C ecosystem as of today is unbeatable. But Rust is catching up, and obviously, we are a big Rust shop in that respect. Okay, so I think a few points. Last points I want to make on this slide is that the wire overhead, or the minimal wire overhead, again, if you negotiate the smallest sequence number and so on and so forth, is 5 bytes, and in reality, the actual wire overhead is 3n plus 2 divided by n, if you are able to batch more messages together, okay? Which very quickly tends to 3 bytes. If you're interested in a wire protocol comparison or analysis, just put a note, and I will put some link to a presentation that I did at the Eclipse conference a couple of months ago that was precisely doing that. In terms of OS supports, I mean, we support Linux, macOS, Windows. QNX is coming. I mean, the Rust support for QNX is still kind of in its infancy, but moving, slowly but moving. And then in terms of embedded targets, here is just an example of some of the embedded target that we support. So Arduino ESP32, Mbed, Zephyr, I mean, usually it's you name it, and you check on Zenopico, and most likely it is supported. Other important things, we also support AutoSAR Classic. That's mostly for automotive, not so much for robotics, but I think it's good to know too. Okay, now let's come to the topology, because this will impact also how we do security. So differently from, let's say, MQTT or DDS or some other protocols, in Zeno, there are no topological constraints imposed over you. So you want to communicate peer-to-peer, fine, you can communicate peer-to-peer in Zeno. You want peer-to-peer to be a full click, that's supported. That's the only model supported by DDS. But in robotics, often we've seen application, especially with platooning, and in combination with radio networks, in which you cannot assume that every peer is able to directly communicate with every other peer in the system. So you have to be able to communicate over a mesh, an arbitrary mesh, which means that peers needs to almost behave like infrastructural node and route data on behalf of other peers. So this is something like the topology that we have on the top right. We have also some use cases that are even more exotic. And again, those are in robotics, in which we have some powerful robots communicating over radio networks through a mesh, and then some less powerful robots, almost think of them as throwaway robots, okay, that are so constrained because they need to be cheap that they cannot afford to be peer, okay? And again, being peer in a mesh will have an impact also energetically, because all of a sudden, right, you are routing information on behalf of other peers. So if you have very constrained devices, you want to be a little bit more egoist and say, no. I'm just going to deal, and take the toll for the data that I need to receive or send. I'm going to be a client, and what you can do in Zeno is that a client can pair up with their closest peer, and then use that peer to communicate with the rest of the system. Okay. We have routers. Our routers are software routers. This software, by the way, I don't know if any of you is using our DDS bridge or ROS2 bridge, or the DDS plugin or ROS2 plugin for the Zeno router. That's all the same, right? Different deployment and packaging scenario. But our router, again, it's a software router. It runs, easily, very well on a Raspberry Pi. You don't need a Raspberry Pi 4. You can run it on a Raspberry Pi 3 or 2. And as such, although you read router, don't think of something that requires, a server to run. No, it's pretty lightweight. And as we will see, the difference between a peer and a router is kind of arbitrary, okay? Because if you look at this slide, you understand that a peer is able to route information as a route is, okay? As a router is. One of the key differences is that the peers has end user logic, a router doesn't, but the router has plugin, okay? Then obviously, you can do a brokered communication if you want, and mix and match this as it pleases you. By the way, make sure that if you're asking question on the chat, I cannot see the chat because I'm on full screen. And today I'm working from home, so I don't have an external, I don't have two screens, okay? So don't hesitate to just speak up. And from time to time, like now, I will pause and say, does anybody have any question so far? Okay, sounds like no. So I'll keep going. Okay, last point. Every router has a plugin framework. Plugin can be used to plug third-party protocols. So we have support for MQTT, DDS, REST, WebSocket, ROS1, and ROS2. So you can bridge ROS1 robots also on Zeno, as well as plugin for databases. Okay, and here are some example of the plugin that we support as of today. Okay, programming model. So in Zeno, we deal with resources. What is a resource? A resource is named data, in other terms, a key value, okay? And So something like home kitchen sensor temp 21.5, it's a valid Zeno resource. And actually in Zeno, there are a series of, let's say, primitive types that are understood natively by the runtime. So you can technically really publish a float or an integer or a string or a JSON, okay? Or whatever else you want, and then you can attach the proper MIME type. Once again, if you want more details, look at, I will share some additional informational slides where you have example of how you actually do that. So we have then key expression. A key expression is nothing but a way of identifying a set of keys, okay, or a set of keys representing a set of resources. So home kitchen sensor star will be all the sensor in my kitchen, and home star star temp will be all the temperature sensor in my home. And then we have selectors. A selector is composed by a key expression, and then you have a question mark and a series of parameters, okay? And these parameters can include where clauses, okay, projections, and so on and so forth. Now, something to understand is that Zeno technically doesn't understand anything that is after the question mark, okay? Zeno uses the key expression in order to route, as we will see, queries. But then the interpretation of what is after the question mark is for, as we will see in a moment, the queryable, okay? Now, if you've used Zeno, we have seen that actually you can do query where there are, let's say, where clauses or time filters and so on and so forth. And this is because in our default implementation of storage plugin, we have implemented, a specific query language that we think makes sense. But there is nothing stopping you for your specific application to implement your own query languages when implementing either your storage plugin or your queryables, okay? So in terms of abstractions, in Zeno, really, there are three things that are visible on the network to some extent, okay? One is the publisher. And again, publisher actually is not something that is compulsory in Zeno. You don't need to declare a publisher like in DDS in order to start producing data. It's sufficient to just open a session and then you can produce data. A publisher is just an optimization that allows us to do some interesting things on the protocol to further reduce the impact on the network when communicating. But a publisher is like a string of value for a key expression. You have a subscriber that is like a sink of value for a key expression, and then you have a queryable, which is like an oracle in the network that tells, okay, look, if you're looking for resources whose key matches this key expression, you can come to me. Okay, that's the only commitment that it has. And you can understand that a queryable actually, could be triggering a query on a database, could be triggering a computation, doesn't really matter. Okay, this is why we can represent both data at rest, meaning querying databases or reading a file system or whatever, as well as triggering computation with queryables. And all of a sudden, we have one abstraction to deal with both data at rest as well as computations. In terms of the primitive, there are just an handfuls. So again, you have open close to open or close a Zeno session. You can declare a key expression. Again, this is optional and it is an optimization. Although you see strings in Zeno, those strings are either explicitly or automatically represented with small integers. Okay, if you want to force the declaration or the association of your resource name to a small integer, you either declare a publisher or you declare a resource. It's just a declaration. You don't need to know. You will never see how we are representing numerically on the wire these strings, but on the wire, as opposed to have a string of 200 whatever, how many characters, you have usually a small integer. This integer is invisible to you and is unique within a session. Okay, that's important because it gives us efficiency without giving you the hassle of trying to manage ID in a global manner, which just doesn't work, doesn't scale, right? I mean, it's just the recipe for disaster. When the day you will end up with two teams reusing the same ID for two different resources, and then go figure out these sort of bugs. They're very hard. So it was a very cautious decision to make sure that the application developer should use things that we understand as human, right? And then the tricks need to be played under the covers, and we just need to provide you mechanisms like declare expression or declare publisher to force us to use those tricks, as opposed to lazily decide when we use. Okay, so that's just to give you some intuition. So declare subscriber declares a subscriber. Publisher, obviously a publisher, declare queryable will declare a queryable on the network. And then in order to operate with on these resources, you can put a key value, you can delete a resource, you can pull data from a pool subscriber, and you can issue a distributed query, which will be targeting the queryable that that match your query. Any questions so far? Because then we'll move to security, now that we know what you operate on in Zeno. Okay, so last point. So Zeno provides abstraction that are universal with distributed system, because all of a sudden, usually when you build distributed system, you need PubSub, you need remote computation, and you need storages. And Zeno gives you all of that, okay? By publish subscribe supported in a native manner, remote computation can be represented as queryable, and storages in Zeno represented just by the conjunction of a queryable and a subscriber. And then we provide built-in plugin, as you saw before, for a series of storage technology like RocksDB, InfluxDB, and so on and so forth. Okay, let's move to Zeno security now. Let's start with authentication. So we saw that in Zeno, the first things you have to do anything is to open a session. Okay, when you open a session, quite a few things happen in Zeno. One of the things that happen is actually authentication, if you have enabled it. And as part of Zeno session establishment, we have an authentication plugin. The default implementation of this plugin provides you support with user password authentication. Okay. Now, I think this is important also in terms of security, but the session opening in Zeno is stateless. So there are cookies that are used and sent back and forth to make sure that if you are trying to open a session with me, I will not keep any state, but I will let you keep the state and eventually get back to me with a proper cookie. Other things that we check when establishing a session, and this is, I mean, for instance, I don't believe that this is done by TDS implementation, because there isn't in the protocol. In fact, there isn't nothing standard that allows you to do that. But something else that does Zeno also makes a check on whether the two applications that are opening a session happen to be in the same memory domain. And why do we do that? Because nowadays, being on the same host doesn't mean anything, right? We can be on the same host, but not being on the same memory domain. And so if I assume that I can do share memory with you, I might be very much disappointed, right? So in Zeno, at session opening, if share memory is enabled, then we will also do a check. Some interesting extensions that are coming up, we are adding support for arbitrary share memory provider. And if you register these arbitrary share memory providers and you make sure that you register the same on both sides, then for all the matching share memory provider, we will do the handshake to check if actually we can really share a memory across those providers. Anyway, so getting back to security, it's important to know that whenever you do a session open, if you have enabled authentication, then by default, Zeno provides support for user and password. It's a plugin. You can implement your own authentication if you want to do so. How do you configure user and password? Well, you can configure user and password on the client side in order to authenticate with routers and get asymmetric authentication, okay? Or you can configure it also on routers and peers in order to have mutual authentication between the router that we connect with each other or the peers that would connect with each other. So just to recap, if you revisualize a generic Xeno topology, so let me go back a few slides here, right? So a client is always asymmetric in terms of authentication with Xeno. So we kind of, the client has to authenticate with the router, okay? Not vice versa. But then for the routers and the peers, for them, it's always mutual authentications, okay? So let me go back here. Now, here, obviously, you see that the password is in clear text. Please don't do that, right? Make sure that you do a SHA-256 or equivalent, and you store hashes in your dictionary as well as potentially in your configuration file. But this is what Xeno provides as one of the authentication plugin and what you can use off the shelf. You have the link to our documentation that provides you more details. Now, we also support TLS as a transport, okay? We can do server-side authentication. So in that case, clients validate simply the TLS certificate of the server, and we are clients and server. I mean, they with respect to the role played in the TLS session establishment. Okay, so if I have a client trying to establish a session with a router, then in that case, the client would be the client and the router would be the server. If I have two routers establishing, or let's say, two routers establishing a session, right? I could have a router on-prem and a router on cloud, and I want to use the same model, suppose, of the web, in which I just want to authenticate the router on the cloud, right? Then in that case, the router on the cloud would be playing the server role in TLS sense, and the router on-prem would be playing the client role. So just to clarify what I mean with client and server in this slide, and when referring to TLS in subsequent slide. So we support both server-side authentication as well as mutual authentication, or MTLS. So depending on your case, you decide what makes the most sense for you. Configuring it, it's pretty straightforward. You still do it through Xeno config files. And that's pretty straightforward for TLS and MTLS. So I think it's pretty standard practice, and nothing breathtaking here. Okay. Now, something else that I think is important for you to know, because if you want to make sure that your system is secured, then as Xeno support a zillion of transport, right? You need to make sure that you ensure that on public, let's say, networks, you only communicate through secure protocols. Okay, so through transport when listing, you can decide for every runtime, okay, what are the transport that is allowed to use on which interfaces. And so that way, you can make sure, for instance, that a router might be communicating only through TLS or exposing only TLS to the network card that is used to communicate northbound with the internet, as an example, or whatever. Okay, but that's a mechanism that is orthogonal to security, but I think useful because allows you to make sure. And if you want to close all the doors, you say, no, man, here only TLS is enabled, and that's it, as an example, right? So it allows you to have control on the set of transport that can be used to establish and to accept sessions by Xeno runtime. Okay, so in summary, a couple of points to be made. First of all, our authentication plugin, the default implementation provides you with user and password authentication, but no, I mean, it doesn't do any secure channel, right? It's authentication. If you think about security, I might already have a secure channel. And in some application, you might be running on 4G or 5G network. Your network is already secured. You're assuming that the secure channel is provided at a network level. You have a VPN, whatever, and you just want to provide an authentication. In that case, this plugin, does the job for you. Okay. There are other reasons why in some country they actually cannot import software with TLS. And so the one reason why we don't want to bind the two and make sure that you can use, obviously, authentication without encryption is that those are restrictions that there are in certain countries. And this is the reason why quite a few open source project takes this approach. Okay. Now, if you need a secure channel, then all of a sudden you could use TLS to establish a secure channel and then do Zen authentication on top. Okay, so imagine the situation in which I'm not using mutual TLS authentication. I'm just using TLS to establish a secure channel with asymmetric authentication, and then I can use additionally Zen authentication, to either mutual authentication at infrastructure level or between peers or whatever. Or you can use MTLS for both establishing mutual authentication and a secure channel between the authenticated parties. Okay, so those are some of the options that you have today. And I will pause for a moment. Any questions so far? I think this is pretty straightforward, but okay.
I have a question.
Oh, yes.
So the primarily secure transport TLS is being applied here. That's built on TCP. Does that limit the quality of service options available when using secure transport?
So if you want to use, so TLS is not the only secure transport that we support. We also support QUIC. Okay, so if you want to use UDP and have a secure transport, you can use, in that case, QUIC. Okay, that will be the other approach to establish a secure transport, and then decide that uses UDP, and then decide how how to skin your cat with respect to secure channel versus authentication. Okay, first point. Second point. So in terms of Zeno QoS, and our experience is that when running over a wider network, right, you are either better off using TCP or QUIC. And plain UDP, we have not seen many. There might be some use cases, but as of today, I think most of the time these two tends to work quite well. And so as UDP, we support as a transport UDP, but as of today, for instance, we don't have a DTLS implementation that would allow us to establish a secure channel over UDP. It's something that could be done. We have not seen the need as of today. Okay.
Thank you.
And then in terms of our QoS, the traffic shaping, the congestion control, and so on and so forth are implemented already at Zeno level. Okay. So if we have time, I can actually go through a couple of slides that explain all the different QoS and what we do. But let's say that the difference between, well, in UDP you have no congestion control, right? When you're using TCP/IP is doing some congestion control already, and sometimes that fights with what, if you're not careful, sometimes that introduces some problems, especially in resuming a normal operation after a congestion. Now, there are tricks to limit that problem. I don't know if you're aware, but what typically we do, we telco guys, is that instead of using just one socket, okay, and this is a very, I don't know if I should say this trick, maybe there are some competitors listening, jokes apart. So what is typically done, right, is that instead of communicating through a single socket, you communicate through multiple sockets. So if you look at Xeno, we have the concept of channel, of transport, but a transport then has links. And so even when using TCP/IP, we have multiple links. And the good things of using multiple links is that all of a sudden, in terms of both recent window and responsiveness in under congestion, you recover much faster. So, I mean, because of all this trick that we play, plus what we do on top, I mean, we have not seen the need to do anything on UDP. Okay.
And then you mentioned Quick.
Yeah.
How would you compare Xeno to something like Web Transport that's also using Quick? Quick is, I mean, Web Transport's more like point to point, but
correct.
in terms of using Quick with QoS capabilities, that might be.
Yeah, but you see, for us, Quick is just one of the possible transport that you see here, right? Then, in terms of the abstraction, with Web Transport, I mean, you don't have the same the same location transparency. You don't have the same support for this kind of topologies. Right, so I think the Web Transport sits at the lower level of abstraction where Xeno is today. Okay, and I'll go back to my slides, which was, I think, this one. Yeah. Okay, so I mean, I need to rush up because we now have still all the part on authentication, on access control. CA. So who needs a CA? Well, everyone needs a CA, right? And that's sometimes a pain in the neck. The good news is that Let's Encrypt is there to help. This is free, automated and open certificate authority that was established sometimes back by the Internet Security Research Group. It's great. And we have, Xeno works nicely with Let's Encrypt. If you want to see how to configure Xeno to use Let's Encrypt, just read the blog that is available at the link shared on the slide. Okay, so the good news is that you want to use TLS or MTLS, and then you say, oh my God, where am I going to get a certificate authority? Or how much is that going to cost? No worries, Let's Encrypt is there to save you, and Xeno and Let's Encrypt work like a charm together. Let's move now to access control. Okay, so what do we need to control in Xeno? Well, usually in access control, we talk about subjects that have the rights to do or perform certain operation on objects, okay? So resources are objects in Xeno, in security terms, or set of resources. And the set of resources might be published, subscribed, and or queried by a given application, which is our subject, okay? Where application really in Xeno term is a runtime that has established a session, okay? Because even within a process boundaries, you could open an arbitrary number of runtimes, if you will. This is why I prefer to use the term object and subject. It's a little bit more generic. Now, something else that you want to control is the scope of distribution and access, because we have some application in which there are regulatory compliance. So, for instance, medical records cannot leave a country, as an example, okay? You might have that, the LiDAR of a robot is not supposed to leave your factory, as an example, right? So there might be multiple rules and multiple cases in which you want to reduce the scope of distribution. And then you have fidelity of distribution and access. This might sound odd to some of you, but actually we experience it every single day. The GPS signal that we receive, I don't talk about Galileo here. Okay, I'm talking about the old style, the traditional GPS signal from the pre-Galileo constellation. But that was intentionally, let's say, reduced quality because the high precision is only available to the military. I don't know if many of you know that, okay? Perhaps yes, but that's an example also of security, okay? All of a sudden, you reduce the fidelity, and that could be done by downsampling, that could be done by some other kind of sampling on the data space when you do a query, whatever. But there might be other rules that you want to do in order to have control on the fidelity of distribution or access to data, okay? And we want to do all of this, obviously, while minimizing the impact on performance. I'll give you another example of fidelity. In high-frequency auto trading, I mean, this is not so much in vogue anymore, but in like 2007 to 2008, that was quite a hot market. But so, for instance, the information provided by the stock exchange to the frequency trader is time critical. And then once the trader had that information, the pace at which they were releasing information to their third party, was time time filtered in a way. Once again, to make sure that they could control, how much value they were giving, because the timeliness of the stock data was essential for their speculation, and they were controlling precisely with fidelity of distribution how downward people were able to actually exploit additional volatility in the market. Anyway, so this is an example of controlling access. Because in this case, for instance, the two robots are allowed to share their LiDAR, but the LiDAR shouldn't get on the edge cloud. But let's get back to another aspect. When we do access control in Zeno, we want to make sure that it works with any topology, right? So we need to be able to do access control at routers level, between peers, between client and peers. But let's start with a simple case, okay? So boundary control, actually, it's quite scalable, and is often one of the ways in which security is performed. And I mean, if you think about a robot, most of the time you might have the robot being a single boundary, or you might have multiple boundaries within a robot, but you still might still be the most efficient way to have multiple routers to divide the boundaries of security inside your robot. This is, for instance, an architecture that is adopted or kind of adopted in automotive, okay? But it kind of makes sense. Why it makes sense? Because if you do that, so if you do security everywhere in a very fine-grained manner, I mean, security has a computational cost, and they will remove CPU cycles for you, or will require you to buy more important hardware. But if you're able to be a little bit more granular, then all of a sudden you can identify an island of, let's say, rights, and then consider those boundaries and do security at the router level. So in any case, in here, every router would have an access control list. And it uses this access control list essentially to take routing decisions, okay? So in other terms, the authenticated subjects will only be able to publish, subscribe, or query the resources that are indicated in the ACL, okay? So if I'm a client down here and I'm trying to subscribe to a resource for which this boundary doesn't have access, then I mean, my subscription won't fail, because recall that in security, you never want to fail something that is not allowed because of access control, because that gives already some information about your system, but you will never receive any data, okay? Similarly for a query, and likewise, if there is a publication and this information is not supposed to go out, that publication won't be forwarded by the router, even if there are subscriber upstreams. So this is quite efficient. I mean, it's implemented, as we will see, as a filter in the router, so it's part of the routing interceptor chains, and it covers quite a few use cases quite efficiently. Now, how about peers? Well, as I mentioned before, actually, a Zeno peer is essentially a router, okay? But a router with user code and without plugin, and without plugin part, I would say for today, because there will be some changes in the future. Thus, once we have ACL on the routers, essentially, we have it on peers for supporting peer-to-peer. And clients, they will always be asymmetric, right? They will be access controlled either by the peer to which they're connected or by the router to which they're connected. And so how is access control is implemented? If you check our branch, there is some routing refactoring going on, and we've introduced interceptors and filters. And as of today, things like rate limiting, access control, and so on and so forth are implemented by means of these interceptors and filters in the routing chain. We are making sure that this adds minimal latency, right? Obviously, it's an extra computation, so it will have some impact. But in ours, we always try to make sure that that impact is either reduced to the minimum or optimized away by pre-computation and so on and so forth that we already do for the general routing case. What is the timing for access control list? So we are working on this now. And as we also announced yesterday, user meeting, the plan is to have ACL in the Q1 release. And all the rest, obviously, access control and user password authentication is already in place. I mean, that's something you can use today. The element we are missing is ACL access control or support for access control, and that's coming in Q1. That was my last slide, so apologies, I'm 4 minutes over time. So concluding, let's say that we keep innovating. We are very open to also feedback and requests from the user. As an example, the Let's Encrypt support was asked on our Discord by a few users, and I think 2 weeks after they had it. Okay, and it's quite useful. So if it's useful for you guys, it's highly likely that it's going to be useful to other users. So usually we are quite keen to do those. Take a look at the user meeting, because there were 10 end user presentation, quite nice presentation. I think can be quite inspiring and giving you a sense of how Zen is being used today and the kind of problem that it's solving. And voila, that's it. I don't know if there are any other questions. Otherwise,
Okay. Maybe a generic one, if you
Yeah.
can hear me.
Sure.
So you mentioned a couple of times that you're moving fast, let's say, and that allows you to provide value immediately. How are you managing the security in your development process? As in, what do you have in place in the company to make sure you don't introduce security problems, right, in the critical part of the code?
Okay, very good question. Thank you, Mirko. So first of all of the bulk of Zeno is implemented in Rust, and that already cuts out a series of potential security issues related to memory management. Second point, all of our commits are signed and done by pull request, and there are actually very few committers on Zeno. Okay, but lots of contributors. And every pull request has to be reviewed at least by 2 committers. Okay, so that's the process that we take. Then that said, obviously you have to pass all the tests. We run systematically. I mean, unless cargo clippy. Okay, so what is cargo clippy? Cargo clippy does static code analysis on Rust, or does an additional pass of static code analysis on Rust. So unless cargo clippy passes 100%, you cannot commit. So there are all a series of good practices that are part of our checklist, automated checklist, right? And this is what we do. Anything you think that we should do that we are not doing?
Well, not that I can think of right now. I wanted to see how long did you put this in place, like all the automated checks? Was it many years ago or recently?
Since the beginning. And by the way, so as Zeno is an Eclipse project, the number of committers or becoming committers requires commitment and an election by the community. Okay, it's not me that can decide, hey Mirko, I like you, you are a committer. Okay, no. So you have to prove that you have contributed sufficiently to Zeno. Then someone has to propose you as a committer, and then there is a formal process by the PMC, Eclipse PMC, that will review your contributions. There is a vote, and if you're voted, you become a committer. But in any case, so I think that's good because it gives keeps the bar very high in order to become committer, and then all commits are signed, and then there are the additional rules that we have in place, like code reviews and contribution only by pull request. Those I think are just good practices.
I have a question on I thought it was really interesting was the aspects of scope and fidelity, particularly like in robotics, limiting the outbound of particular internal topics, so they don't propagate beyond or as well as concerning the fidelity. So maybe like RGB image space, something you don't want to propagate too high D or HD to cloud services to either preserve privacy or something like that. You mentioned a prior talk where some of the current users were presenting some of their use cases. Did some speak to that those aspects of scope and fidelity?
No, they didn't. But let's say that I'm familiar with that because that's a very sensitive topic in aerospace and defense. And so as historically our technology has been used also in those domains, I think we have quite a bit of experience. Because this is not something that on average an IT security person just coming from IT thinks about, because that kind of way of thinking doesn't belong historically to IT. You see what I mean?
Yep.
Yeah.
And maybe something analogous in the DDS security spec, you have permissions for read, publish, and also this concept of relay, which I don't know is used very often. Is there a similar aspect of whether certain identities in the network have permissions to relay topics on other people's behalf, and then that has sort of a chain of signatures and how you can verify whether something was properly relayed?
Yeah. So the in Zeno, right? Every peer can actually route data. So that's not an exception. It's kind of the so let me actually step back. The relay there are two use cases for DDS. Okay. In DDS, I can produce data. I can send you a message on behalf of somebody else. Okay. And that there is, let's say that what DDS gives is a way of annotating a message to tell you that who is the original writer. Okay, because you will get a data sample from me, and I can tell you with a sub message, look, the original writer actually, is Florencia. Okay, as an example, and the DDS security allows you to make it possible or not, right, to do this kind of forwarding. Then the logic that used to do the forwarding, you had to build it, or the vendor provides it, whatever. In Zeno, right, every peer is able to route information. So for us, it's not an exception that you are receiving data from me through Florencia which send it to Mirko and then send it to you. So the model is completely different. Okay, the reason why DDS needs to annotate explicitly is because the DDS model is that everyone knows everyone else. And I always, if I need to talk with you, I will always talk directly. In Zeno, in fact, and this is one of the challenge also for security, but in Zeno, you don't need to know me. And in fact, most of the time, you have no clue that I even exist. If I'm a publisher, and likewise, if you're a subscriber, I have no clue that you exist, nor how many of you exist. Okay, and Zeno does this intentionally because otherwise it's very hard to scale to a very large scale system. So I just want to, I know this sounds abstract, but let me give you a concrete example, and then I need to jump on another call. But that's very fundamental for scalability, and it was done intentionally because you understand that, you know, we understand it as well, and we didn't want to have the same challenges. So in Zeno, we have resources, right? Now imagine I have a subscriber for kitchens. Okay, let me do like this. Let's do a clean, an empty slide here. Okay. So in Zeno, suppose that somewhere on the system I have something like a publisher called for this resource, and I have a zillion of this, okay? In DDS, what would happen is that all of this information will be propagated as individual discovery information, okay? So a subscriber would know that there are, you know, 200,000 in their case topics with name home, kitchen, sensor from 1 to 200,000. Okay. In Zeno, what actually we do under the hood, and we take the freedom to do, is to propagate across the network this. You don't need to know anything else. You need to know that there is interest in order to route. And then when you receive the data, you know from who is coming. Do you see the difference? I mean, this is why if you look at some of the reduction in discovery traffic that people are measuring, it's like 96, 97, 99%. People say, how the hell are you guys doing? Well, it's a different model. And the way that I always say is that think of the discovery that DDS does like a set, a mathematical set. DDS enumerates all the elements. And what we try to do, Zeno tried to give you an expression to represent the element that belong to that set. And all the time we try to compress this. Maybe, you know, some other portion of the network, we propagate this, or even this. And that's good, right? Could be this or could be this. You have no control of what the heck we do under the hood, but we always try to minimize discovery information and to propagate minimal information that is required to let the data needs where it needs to get. Okay, and I think we have to stop. Unfortunately, I have to jump on another call. I hope this was interesting, but guys, I'm pretty happy to come, you know, later on if you want, and maybe we could, once we get closer to the first release, we could actually, you know, come and give you some more details if you guys are up for it.
Yeah, yeah.
Yes,
So
please do.
I brought it here, but we can collect questions and we will try to provide some answers offline. Right? So no promises. I cannot talk for you, Andrew, but yeah, we can collect questions at least.
Yeah, of course, and you know, I will answer. Just a warning: I will be traveling in Asia the entire next week, and I'm on a completely crazy schedule. So I might answer when I'm back, just to. But yeah, so that doesn't look like the right address. But anyway, so we are also on Discord, and we were on Discord since before, let's say, the ROS moved on Discord. So if any of you are on Discord, don't hesitate to join the Zeno server. The second address is the right one, and you can also ask a question there. I mean, we are super responsive. Okay.
Thank you a lot. It was very interesting.
Okay, thank you very much.
Well, thank you so much.
I
See you
will
next time.
yeah, so Mirko and Florenza, thank you for the invitation. I will send you some more material because there were far more things that I would have liked to cover, but we have, you know, a nice webinar and quite a few video available and documentation online. So that's a good source of resources too. And, you know, whenever you want, just ping me and I'll be there.
Okay. Thank you.
Yeah, perfect. I was going to say more
you.
times to ask lots of questions. So yeah, let's continue the conversation.
Sounds very good. Bye-bye. Thank you. Bye.
Thank you. Thanks,
Ciao.
Angelo.
Bye.
Thank you.
Thank
So-
you.
Bye.
Bye-bye.